This video will cover the first page of notes for the topic of applications of logs and exponents. Before beginning the notes, let's watch a short video.
What does the coronavirus have to do with mathematics? Ever heard the term viral? When we create a video at Don't Memorize, we hope that it will go viral. But what does viral exactly mean? Yes, it's true we want a whole lot of people to view the video. But look at this daily chart of views recorded. Is it viral? The line is straight. It's a linear growth. What we really aim for is exponential growth. But do you truly understand what exponential means? It is the rate of change over a given time period. It is something we refer to in the real world as compounding. So, if we get 1,000 views on day 1 and each subsequent day we get 20% more views, day 2 we will have 1,200 views, day 3 will be 1,414 views, and look at the staggering number on day 30. 237,376 views. For the same rate of growth, with passage of time, the growth seen for each time period increases immensely. That is the power of compounding. That is exponential growth. Viral infections spread in this manner, and hence anything which shows exponential growth is referred to as viral.
As you can see, the notes on this page will not be on the test. However, I wanted to point out that the video mentioned that exponential growth or exponential equations are dependent on the word compound or compounding. So I want to cover the notes so that we can see where compound interest is going to come in. For the moment, I'm just going to sit here and say that compounded interest is what works in terms of banks, credit unions, and credit cards. My credit union, for example, will give me a quarterly report. That means they give me interest or money 4 times a year. That means every 3 months I get a statement saying how much money I earned. And they base it on this equation, where A is how much money I have altogether, P is how much money I started with, R is my interest rate, and we write that in decimal form, T is how long I leave it in the account, and N is how often they give me the money. So like I said, if they give it to me 4 times a year, that's called quarterly. That's the number of times that they compound my money per year. So you can see a couple of examples where we have Becky who has that needs $6,000 in 5 years. So how much money should she put in the account so that it will compound annually, that's once a year, and grow to the $6,000 she needs? So we know how much we need. We don't know how much to start off with. We know the interest rate is 2.9%. N is equal to 1 because they're doing it annually. And then T, she has 5 years to leave it in there. And so we know everything except for P, our principal. So I just want to let you know that we can go in and solve these. We're not going to do it for this particular test, but I want you to get the idea about compounded interest and how that is calculated. Because what if we could sit there and do it every day? So that means that instead of N equaling to 4, then N will now equal to 365 times per year. That's every day. But then we could also increase that to be every hour or every minute. And we can see how this number of N will go really big. So let's talk about what happens if we let N go towards infinity. That concludes this video.